and you then update your marking in your table. Okay, so I don't think we would have time to go through various cases of this. It turns out that this approach would also fail in certain small number of scenarios. Question?
I had sort of a fundamental question about this approach. So you said, or like in the beginning of this talk, that if we just do ingress filtering, it does not provide incentives. But if we do this marking technique, it does for this the claim, or
Yes, yes,
okay.
yes. That's a good question, actually, because that's fundamental to why you would want to incur additional overhead. See, remember what we are doing. We are doing ingress filtering, and we are doing everything else. We are doing an extra lookup on your routing table, and you're having to generate this information in your routing table. Why would you want to do that? Because the problem is still the same, that if everyone was deploying ingress filtering, you would not have a problem, right? Because then you almost like form a shield in the network. If some people are not deploying it, that problem is still the same, partial deployment. So how are we providing incentives? So I'm sorry that this point didn't come across earlier. But when a router verifies a marking, what does the process of verification mean? It looks at a source address in a packet and it says, oh, this marking is actually correct versus not. I expected this marking to be something. So either the marking isn't there or the marking is an incorrect one. Then it drops the packet. What that helps is, if you are deploying, if you are a network who's deploying, which means your packets would travel to the next deploying router marked, and someone else is trying to spoof you, that router, if that someone else proceeds encounters a deploying router, their spoofed packets will not make it. Let me try to say that again. So here's a deploying network, and there may be other non-deploying networks in the middle. And here's Trudy. Here's you. So you mark your packets, and the router verifies the markings, and it sends them to whatever destination you're sending them. So your packets are going fine, just as they would in the case of ingress filtering. In fact, you're incurring extra overhead at the routers, right? Because you're verifying the markings at every step, stripping off the marking, etc., etc. However, what ingress filtering didn't give you is that when Trudy tries to generate a packet saying it's coming from you to whosoever it wants and the packet, this goes to this or any other deploying router in the internet. Let's say it goes to this one. It says, oh, your packet doesn't contain the marking that I expected from Trudy's packet doesn't contain the marking it expected from you. Drop it. Which means I am not just doing ingress filtering and putting a marking for the benefit of others or in general. I am being given an incentive to put this marking, because if someone else tries to deploy me, to spoof me, and they encounter a deploying router, they will get dropped. So hence the incentive point.
I thought the incentive should be on the side of the router. What is the incentive for the router to implement such a technique? Obviously, if I'm sending the packets, I would like to mark them to guarantee.
Okay, so let me ask you a reverse question for that. What is the incentive for a router to do routing? Why do those poor things, they cost pretty close to $500,000. Why do those poor things exchange all these packets on the internet for your goodwill? No, there is incentive for them to deploy because the ISPs are getting paid to carry traffic. So the routers have no problem deploying it. In fact, if you could convince them with minimal overhead, they can actually accomplish this. A lot of ISPs would like to have this functionality, right? So I didn't get into this, but this also, the recursive router challenge also fails, and there's another approach, but at the end of it, we can cover all cases. And we don't have time for any of this. So I guess we'll skip evaluation. The point of the evaluation here is that, one, under partial deployment, we can actually prevent spoofing. And to what extent you can prevent spoofing at what deployment percentages. That's one aspect of the evaluation. And does marking learning actually happen if you try to keep the size of the fib table at the edge routers just as short as it would be in the normal case? It turns out that you can learn markings in that case. However, how much can you learn? And even if you exchange the learned markings with everyone, let's say you set up a website and you show the markings to everyone and charge some money for those markings, it turns out that you cannot exploit the learned markings as much as you would like to, because the markings have direction information in them. So just learning the marking doesn't help you exploit all the routers. So I'm sorry we couldn't get to the end of it, but I hope I was able to communicate some of the basic ideas here.
We never got to how the markings evolve. Is there any relationship between one marking and when it evolves into another marking? Is there a notion of distance between them? Or is it a random chain? You see, the idea is that if there is a notion of distance, by drifting slowly, it phases out the old one, and then you have a threshold scheme where I don't expect the marking to be exactly the same to accept it, as long as it's within a delta. And then you have them drift slowly over time, and it would be very clean.
Yes. So some of the practical considerations, again, that we didn't go into is, what is the format of the marking? Where should it be put in the packet? An easiest thing to do would be IP options, but that means that routers actually don't process IP options in the fast path, so you actually would go in the slow part. That is one aspect. The other is, so marking format as in size. The bigger the marking is, the harder it is to guess. Remember that we are not using cryptography. So any marking you put can be guessed. So the longer it is, harder to guess, right? Location of the marking is another thing. Third is changing of markings. And change of markings could be you just randomly switch to another marking and the router does whatever it did earlier to learn the markings. It does the same thing. That's one approach. The other approach that has been used in some earlier work is the notion of hash chain. So the router actually sends you this hash chain ahead of time. And it has essentially information about, let's say, 20 markings. And it changes from one marking to another, and you can still verify up to 20, at which point it explicitly sends you another hash chain. However, this notion of delta would be interesting, but I haven't seen anyone.
We need to talk because you don't need to have the reset after 20. You could have an open-ended hash chain.
Okay, so I'm not that familiar with
you're thinking of a hash chain in a certain way, but there are ways of making the hash chain open-ended.
Yes. So that would be basically the issue is that since markings can be learned, you want to minimize the damage that can be done from the learned markings. So you want to change your markings. And there are pretty slick approaches where once you've learned a marking, they can change within certain parameters and you can still basically